Okay, so now we're looking at dominant air masses in North America, let's say, right? So an air mass typically takes on the characteristics of the surrounding region, let's say. If it's above cold water, the air above cold water will typically be colder in temperature and contain less moisture than the air above warm water, right? So, and the air above land, let's say then, will be warmer or colder depending because of the lack of moisture and thus the its ability or inability then to retain heat and other things. Okay, so we got key terms in the bottom right corner here. So our key terms, we've got maritime, continental, polar, and tropical. So I always like to kind of divide those two, because what you'll end up with is maritime or continental and polar or tropical. If we were to try and think of some thesaurus type words or some alternate words for these, let's try and think of a few. Think of a word you could sub in for polar. There's an obvious easy one. Okay, if we're getting a simple word for polar, I think it would be fairly easy to get cold. Okay, now give it a shot for tropical. Okay, so I guess you could probably say warm, hot, something along those lines. I think you're seeing the obvious concept that you have polar is cold and tropical is warmer. Now if we go to the other side and we get maritime and continental, a little tougher, sure, but if we're not talking temperature, we're likely talking precipitation or moisture. So maritime, let's sub in an easy one here. Wet. And then if we go continental on the other side of that then, let's get dry. Okay, so let's do a quick quiz here. If you had a wet and a warm air mass, it would be a maritime tropical air mass. If you had a dry and a cold air mass, right, a continental polar air mass. Okay, so you got it. Okay, so now we have dominant air masses. Again, where does our wind direction come from typically where we are? It typically comes from the southwest, right? So everything is kind of being pushed, typically, in this general direction all the way there. Sorry for the black mark. So pushed in this general direction all the way across. Why? Because we just did previously the Coriolis effect and its effect on the global wind circulation pattern. So now we have some dominant air masses. So I always kind of just draw this fairly easily here. If you end up with something like that, something like that, something like that. Now it's definitely imperfect. So we're going for something like a bit of a Batman logo here. Okay, now this one, to be fair, is drawn somewhat incorrectly, but it's not the biggest deal in the world because you could visualize it. Okay, so we have, let's say, 6 dominant sections here, right? 6 dominant sections. Okay, and so those 6 dominant sections are going to retain characteristics here based on their location. Let's say visually here, would the water here be warmer or colder than the water here? Slightly colder, of course. So this is existing over water largely, except for Alaska, sure. Over water largely, and further north. So we're going to call that a maritime polar air mass. Now, don't ask why. It's kind of like the pH in science. It's small m, big P. I don't know. I'm not sure. It's just a silly little thing that we like to do sometimes. Okay, so now let's get rid of the other obvious one here. If this is further south than the maritime polar and we're saying it's a different air mass, we could then call it a maritime tropical air mass. Okay, so then we could do the exact same thing here because it's over water and it's a warm air mass, right? Will this typically affect us? Certain times it affects storms and things going this way. But again, our wind is likely in Canada, anywhere in Toronto where we are, blowing across that way, predominantly. Not always, of course, because of local weather circulations and all the rest. But this air mass is not our biggest system, except for some storms throughout the course of the year that bring up this kind of moist air this way. And we'll get to more of that later. Okay, so this one's an easier one then as well. We've got another maritime polar air mass. North and over water, south and over water. Okay, so this one, you can either see it called a continental Arctic or a continental polar. It's typically in the middle of the country. Now I get it. When you look at this, you see a lot of water. However, that water is frozen for part of the year, very cold for the rest of the year or a lot of the year, and so it's not releasing a ton of water vapor. So it's over top of predominantly a dry climate, so a dry and cold climate, continental polar air mass. This is that cold Arctic air that we get blasts of in the wintertime and causes cyclonic precipitation other times then as well. Okay, and then lastly, we've got an air mass here. Now I said I drew that somewhat incorrectly. I prefer if this was actually further over here, but again, it really doesn't matter. Because this air mass I'm drawing here right now, it can't be anything but a maritime tropical air mass. Think about it logically. It's coming from the Gulf of Mexico, it's coming from the east coast of Florida, the Caribbean here. It's gonna be wet and it's gonna be warm. If it's wet and it's warm, it's gonna be maritime tropical. Okay? However, why I said I want to draw it in here, because I think anytime you get an air mass coming from the Midwest, let's say, you can easily get dry, warm air coming up from all these 10 or 11 states in the southwest of the United States. So that could possibly be a bit of a continental tropical air mass as well, which is pushed in our general direction. So 7 air masses, whatever you want to say, that obviously change, have different characteristics, and intermingle, let's say. And when they intermingle, they get into somewhat altercations with one another. The altercations they have with one another cause precipitation. Okay, that's it.